Hello, good morning. This is Tahmina Khan, TK. Today I'll explain you in this video the differentiation of product and quotient of two polynomial function. This is a topic covered in O-level Add Maths, and I hope you know what is polynomial are. Do you? Okay. So polynomial is an expression of more than two algebraic terms. So for example, 2x square plus 3x plus 5. So these are polynomial. If you want to see the differentiation of other three functions, because in the syllabus we have four type of functions: polynomial, trigonometric functions, exponential functions, and logarithm function. So if you want to see the differentiation of these, you need to see my other video in which I have explained the basic differentiation of all these four types of video. So coming back to the topic, we will see here how to differentiate two polynomial functions which are in the product form or in the quotient form. So let's just start with this. Okay, when I'm saying a product function, it means two functions are multiplying. For example, u and v are my two functions. I'll take an example. Right now I'm just generalizing a formula here. When we have two functions u and v and they're multiplying, so the differentiation will be u times differentiation of v plus v times differentiation of u. Similarly, when we have, and this is written as u v prime plus v u prime. So this means u multiplied by differentiation of v plus v multiplied by differentiation of u. And when we have the other function which is in the quotient form, like this algebraic fraction type, so the differentiation of this will be v differentiation of u minus u differentiation of v and divided by v square. We will see the application of these formula in the following example. But before that, let me just help you to recall that whenever we are differentiating a polynomial function, because I'll make use of it again and again. So if it is a single term, you multiply by the power, the coefficient multiplies by the power when you're differentiating, and then power is subtracted by 1. And this is a symbol of differentiation, y prime. It is written like this, or also dy over dx. In this one you can see I have taken a composite function. So composite function, on the linear function you have a overall power. So if you want to differentiate a composite function, you must remember that you multiply the linear function by, it could be quadratic, anything can come here, it's not linear all the time. I have taken an example of linear right now, right? So you multiply the function in the bracket by the power. The function remains as it is, and then you subtract the power by 1, and then you multiply by the differentiation of whatever the function is written here, expression is written here. So the differentiation of ax is a, and differentiation of b, which is a constant, is 0. So hence you will get a n bracket ax plus b power n minus 1. So let's see a few example of product rules. Okay, so I have taken all the examples here, 4-5 examples from exercise 15.3 of Add Maths book. So they are from the exercise. So first example I am taking, y is equals to x minus 1 and x plus 2 whole square, and I have to find out the derivative of it. Derivative means first derivative is differentiation, which give us gradient function. Gradient function and all this I have explained in my other video, in which I have explained differentiation of 4 basic function. So my u is x minus 1 and my v is x plus 2 power 2. So there are two functions which are multiplying. I have given them name u and v. So according to the formula, I need to find out v prime and u prime also. Means derivative of v and derivative of u. So we know from the basic function that the derivative of this will be 1 minus 0, which I have not written here, and the derivative of v will be, because it is a composite function, it will be 2, it will become multiplier function as it is, 2 minus 1 is 1, and then why this 1 is coming? Because I am multiplying by the differentiation of this function, which is 1 plus 0. So I have written 1 here. After that I have simplified. So now I have u, v, u prime, v prime. I'll substitute these values in this formula, which is the derivative of product functions, right? Product rule. It is called product rule. So now I'm simply substituting u is x minus 1, v prime is this, you can see. So after substitution these values, I am simply simplifying them, using algebra, expansion of the brackets. But what I'm doing here, I'm taking the common out. If you look at this term and this term, what do you find common here? X plus 2. So I have taken out x plus 2 common here, and then simply I'm opening the brackets, and this is my derivative of the function. This is actually, if you remember, is a gradient function. If I plug in the value of x here, for example 2, I will get the gradient on the curve at that point. So we will see it later. Now let's see the other example. Okay, this is example number 2. As I said, I have picked up all the examples from exercise 15.3. So now I'm saying this is my u and this is my v. So according to product rule, the derivative of u into v is u v prime plus v u prime. So I will now differentiate these two functions separately here. Here I have done that. So differentiation of x square plus 6 is 2x plus 0, and derivative of v minus 2x minus 4x square is 0, because the derivative of 1 is 0, of minus 2x is minus 2, and minus 4x square is minus 8x. So now I have u, v, derivative of u, and derivative of v. So now I'll simply substitute these values here, because this is the differentiation of this function. So you must know that derivative notation is like this or like this, and there is one more way which we'll see later. So both these means first derivative, means differentiating first time. So here I have plugged in the values, simply plugging in, nothing else, right? So now I will simplify them. If you notice, I'm just rearranging here, taking common 2 out from here, which I have written here. This is as it is, and after taking 2 common out, what I'm left with, minus 1 minus 4x. And here I'm just bringing this 2x from here to here. So rearranging, bringing it into simple form, easy to understand. After that, from this term and this term I'm taking common out. Usually when we write the derivative, we leave it in the simplest possible form. So that's why we are doing all here. And at times in exam it is said, show that it is this. So when you have to show, you have to bring it into that particular form. Anyway, after taking common out, now I'm expanding the brackets. Reason, I can see that there are like terms. So like terms I have to add up or subtract accordingly. So after that I got this expression. So this is my gradient function. So let's see another example. Okay, so this is example number 3. This is also from the exercise 15.3. Now at a glance it looks like, and it is, that we are multiplying 3 functions. And we have learned the differentiation of 2 functions. So in my experience, mostly students get stuck at this question. So simple way is to multiply these two, and then now it is in the form of 2 functions. After that we will simply apply the product rule, which is u v prime plus v u prime. So now if you look at here, this is my u and its derivative is 3x square minus 2x. Why? Because 3 comes here as a multiplier and then 3 is subtracted by 1, which is the basic rule of differentiation of a polynomial, of a single term. And similarly here I have done 2 come here as a multiplier and 2 minus 1 is 1. So now I will show you here the differentiation of second term, which is v. So this is my v. So when I will differentiate it, power will come here as a multiplier. Function will not change, it will remain as it is. And then power will be subtracted by 1. And multiply by the differentiation of this function, which is 0 plus 6. So after that I am just rearranging it. And minus half mean if I take it in the denominator it will be plus half. And when you change this index form, whenever it is in the power it is index form, into radical sign, a square root sign. So power half mean it is root of the number or the function, whatever it is. So now I have u, v, derivative of u and derivative of v. So now I will simply substitute in this formula here, right? So this is the derivative of two functions. So let's see here. So here I have substituted the values. I have done nothing, no simplification, simple substitution. Now I will start simplifying it. Now if you see here, the denominator here is what? 1. So I will take LCM. So this term as it is, right? And when I am taking LCM, I'll multiply this side by 5 plus 6x. So when root 5 plus 6x multiply by root 5 plus 6x, what we are left with? 5 plus 6x. So in this stage I have only taken LCM and simplified it. Now after that I am expanding the bracket in the numerator and adding and subtracting like or unlike term. You can see here. I hope most of you know that when root of two same terms are multiplying, then root is gone and it is only a, because half powers added up, half plus half is 1. So that's why it remains like this. So this is what exactly we have done here at this stage, right? So I hope you understood that how we are differentiating it and getting this answer. Now I will explain the same question by the I will do it that later, sorry. So now I will take example number 4, and it is show that the derivative or the differentiation of this function, which is here, is equals to this. So these type of questions are a little easy for students because they know at least what answer they need to get at the end. So coming back to the question, so this is my function and I can see that it is a product of two functions, this one and this one. So I will apply product rule. So I'm taking u as x, sorry, x as u, so derivative of x will be 1. And the derivative of v, now this function is my v, again I'm explaining, half as it is, half minus 1, multiply by the derivative of this, which is 0 plus 2x. So it is coming here. After that I'm just simplifying it. This 2x comes here because it is multiplying, I'm cancelling it out, and half minus 1 is minus half. And then I'm writing it in the denominator because negative power, when it goes in the denominator, according to law of indices, it turns into positive. Okay, so now I have u, v, derivative of u and derivative of v. So I will simply substitute in the product rule, which is this. So I'm plugging in the values here, you can see u, v prime, v and u prime. Okay, so I have substituted the derivative here. Okay, after substituting the values, I'm simply taking again LCM because there is 1 here. So this will multiply by this, and this is what I will get. Then will I leave it here? What do you think? No, because there are like terms, so we need to add them up, right? So it will become 2x squared plus 3. So this is my derivative or differentiation, and which is actually a gradient function. So if you don't remember about gradient function, we will see in the next example. Okay, it helps us to find out the gradient at any particular point of the function. So let's see the last example of the product rule. Okay, so this question is about calculating the gradients of the function at point where it crosses the x-axis. It means where the function is crossing the x-axis. At that point, what is the rate of change of function? I don't know how many of you use Desmos graphical calculator. I'll show you here at the end of the question that it really helps a lot in the class to explain a student what we are trying to say. So the meaning of this question I'll explain you through graphically using Desmos, right? And you can also use it. It is online free graphical calculator. So it will really help to get the visual understanding of the meaning of the question. So anyway, right now the meaning of this question I'm explaining is this, that you have to find the rate of change, gradient mean rate of change, or the slope at the point on the curve where it is passing through the x-axis. So to find the gradient function, I need to find the gradient function first. So I will differentiate this function, right? Again, it is in the form of product of two functions, this one and this one. So I will apply product rule. So first of all, I need to differentiate u and v so that I can substitute the values in here. So you can see here, we have done in the previous examples, 3 will come here as a multiplier, 3 minus 1 is 2, function as it is, multiply by the derivative of this function, which is 1 plus 0. So this is I have gotten here, and v is x minus 1, so derivative is 1 minus 0, so it is 1. So now I'm substituting these values in the product rule, and this is what I have gotten here. It is simple algebra, very simple equation, but I wanted to explain the concept of gradient where graph crosses the x-axis. That's why I have picked up this question. So it is a simple calculation, and mostly students ask him is, can I expand this? There is no need. It's a common factor, and you know, simplified form is always a factorized form. And secondly, we are using this function to find the gradient of the curve at particular point. So it's better to leave it just like this. So this is your gradient function, and now question is saying find the value of the gradient where the curve crosses the x-axis. So it means what is missing here? Because I need to substitute the value of x here, and I don't have the value of x. So can you tell me where the curve crosses the x-axis? How can I find the value of x at that point? So to find the x-coordinate at that point, where you have to find the gradient, you will put y equals to 0. Because you must remember from coordinate geometry chapter, which you have done before, that on x-axis the y coordinate is 0. So that's why in the function, which is this, I will substitute y is equals to 0 to get the values of x. And at those values, on those values of x, I'll find the gradient. So I'm simply substituting y0 here to find out where the x is the function is crossing the x-axis, on which points. So this means simple algebra you have done before. So I have found the two values of x, -1 and 1. It means there are 2 points on the x-axis through which curve is passing. Okay, so when x equals to -1, I'm plugging in the value in the gradient function, which was this. We have just found on the previous page. So I'm substituting the value of -1 here. and I got 0. And then I am substituting the value of x 1 because we found two values of x again in the gradient function, and I got 8. It means on the curve the slope at x equals to -1 is 0 and the slope at x equals to 1 is 8. Now I have drawn a rough sketch of the graph here for you, and I'll show you on Desmos also in a minute, that this is the point through which the curve is passing through the x-axis, and this is the point. This is +1. So slope here is very steep. Okay, so that's why gradient is also very high, which is 8. Whereas here it was almost on the x-axis, so that's why gradient is 0 here, right? So now let me show you on the Desmos. Okay, so here is a Desmos. I have just typed the equation here, you can see, and this is the graph I am getting here. So if you look at this graph at x equals to 1, the graph is very steep. If you notice here at this point, so it is 8, whereas at -1 it is almost flat, right? So that's why the gradient was 0 here. So you can also type it on your web address on the Google desmos.com and you will see this calculator. I have found it very useful, always very useful to explain to the students that visually they understand better. So I think I am done with the product rule with this question. Since I always keep the length of my videos around 15 to 18 minutes and it is almost 21 minutes, so I will cover the quotient rule in my next video. Thank you very much for watching this video. If you have learned something or if you think it is useful, please do press the like button and do give me comment. Your comments will will be encouraging and I will go for more videos. Thank you very much.